In section 13 of chapter 13, Klein's second edition organic chemistry textbook, they're starting to talk about synthesis strategies. We saw a lot of this in chapter 12, going from an alcohol to an alkyne, going from an alkene to an alkyne, or maybe going from an alkyl halide to a alkyne, something like that. And we had this map. And this figure here, you can see, is a much greater, larger atlas of functional group interconversions. You can interconvert or change one functional group to another, and there are only a certain set of reagents that allow you to do that. Now, there are some functional groups that are lacking from this, and I just want to add the carboxylic acids. Now, remember, if you take a terminal alkyne and you treat this with ozonolysis, ozone and water workup, you can form a carboxylic acid. A carboxylic acid is a very important functional group. There are a dozen or so reactions that you can do starting from a carboxylic acid. Now, primary alcohol and the Jones oxidation can give you the carboxylic acid, okay? So that's going to be your chromic acid, okay? Now, we've learned a lot of these reactions, and these should be put to memory using flashcards, using lots of practice. Now, I want to do problem 24, parts A through F here, just to illustrate how you would use this atlas of functional group transformations. So here in yellow, I'll just highlight where we are and where we're going. So we're starting with an alkyne. Okay, that's a carbon-carbon triple bond, and we want to form an alcohol. Now, you can think of each of these functional groups in these boxes that are bolded as international airports. There's a lot of flights coming in and going out, but there's no direct flight from an alkyne to an alcohol that we know of, that we've taught you in this class. So what we need to do is think about, okay, how are we going to get there, okay? And this is where this map is very helpful, okay? Now, let's go ahead and think about how we could change this alkyne to maybe a ketone or an aldehyde, and go from a ketone or an aldehyde to the alcohol, okay? So what I'm going to do is change this alkyne to an aldehyde. The aldehyde I want to make looks like this. And remember, whenever you're doing synthesis problems, you want to count the carbons and see if there's a change. You also want to look, obviously, at the functional groups. How are they changing? I've already counted in my mind, I forgot to explain, that in the starting material I see 7 carbons, and in the product I see 7 carbons. So since there's no change in carbon counts, I don't need to worry about introduction of new carbon-carbon bonds. Now, to go from an alkyne to an aldehyde, I'm going to choose the hydroboration route. I normally write this as BH3THF. Okay, and we want to use basic hydrogen peroxide to get to the aldehyde, all right? Now, from the aldehyde to our alcohol, we want to do a reduction. Either of these two reagents will do the job. I'm going to choose to use sodium borohydride and methanol. Okay, so either of these two reagents are okay, but for the first reagent, you need to use hydroboration procedure to give you the anti-Markovnikov product, the aldehyde. If you use this route, that would give you the ketone, so be careful about that, okay? So this is a 3-step synthesis. Let's look at this reaction here. We're starting from an alcohol, and we're going to an alkyne. Now, it is possible to go very lengthy through the procedure, right, and take a very long route. If it gets you to the product, that's correct, but sometimes we just like to try to find the shortest route. And here I can see, just from the arrows in my map, that I can go from an alcohol to an alkene, and then I can transform that alkene to an alkyne, like we saw earlier in chapter 12. So to go from an alcohol to an alkene, which is a reaction we learned already in this class and reviewed it, is we can add acid and heat and that will give me the alkene. Now to go from, and that's right here, H3O+. Okay? Now to go from an alkene to an alkyne, I want to add bromine and then NaNH2. Okay? This book likes to emphasize the fact that you add water at the end. Okay? In my class, you just need to show the NaNH2. All right? So that's the whole procedure to go from alcohol airport to alkyne airport. All right? In this next problem, we're going from an alkene to an aldehyde. Where's the alkene? Alkene's right here. Okay? And aldehyde's way over here. So we want to devise a flight path. And it looks like we could go either way, right? We could go to an alcohol and then to an aldehyde, or we can go to an alkyne and then an aldehyde. I'm going to choose to go this route just because I have to choose one possibility, okay? And we have to decide, okay, there's 3 different possibilities here. There's a hydroboration, alkoxymercuration, demercuration, or acid and heat. So how do we go from this alkene to an alcohol, all right? And you want to look carefully at the carbons here. We want this carbon at carbon 1 of my alkene to become the alcohol-bearing carbon. So the way to do that is through hydroboration technology, okay? So we want to choose this reagent right here because we know it adds anti-Markovnikov. The OH will be on the very end of the chain. So BH3THF, basic hydrogen peroxide, okay? And that will get me to this alcohol, all right? Now to go from that alcohol to the aldehyde, what do I need to use? Now there's this choice here I need to make. Now remember, a primary alcohol can be oxidized with PCC, and that stops at the aldehyde stage. So that's what I want to do, okay? I want to choose PCC, okay? And we all know PCC is going to be in dichloromethane because that's the non-aqueous solvent that allows this to stop at the aldehyde, all right? So this is a couple-step reaction, okay? 2 flights here. This next problem, D, we're going from an alcohol to just an alkane. So here's my alcohol, okay? And here's my alkane right here, all right? So if you look, there's really only one flight going in, and it comes in from the alkene. So I need to think about how am I going to make my alcohol go to an alkene, okay? The way I'm going to do this is with concentrated sulfuric acid and heat. Okay, and we'll call that step 1 there. So we're doing concentrated acid and heat. So there I am. I now have an alkene. And now I want to convert that to an alkane. And I do that with hydrogenation. Okay, hydrogen and some suitable catalyst. All right. For letter E, let's count the carbons. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so thankfully there's no change in carbon count, but there is. It looks weird. It looks very weird to me, but it has 4 carbons. So basically, all we're doing is we're removing this oxygen. Maybe I'll still keep yellow, and I'm going to add a double bond between those 2 carbons. Okay, so let me erase that writing there. So let's look at our pathway here. We're starting with an aldehyde, okay, that's this box here, and I want to go to an alkene, okay, an alkene. So what I think we should do is notice that there's only one way out of this box, and that's to go here to an alcohol, okay, go to an alcohol, and then the alcohol can be converted to an alkene. We've seen previously how concentrated acid and heat can convert alcohols to alkenes. Now, how do we go from an aldehyde to an alcohol? Either of these two conditions or reagents will work. I'm going to just choose LaH and water this time. Okay, so that will get my primary alcohol, and then I can add acid and heat to give me the alkene. Okay. Now, what about letter F? I'm going from a ketone to an alkene. So it looks very similar to the previous problem we just did. Ketone would be in this box. Alkene would be in this box. And so what we need to do is convert this to an alcohol and convert that to an alkene. Our alcohol here is just going to be a secondary alcohol, but that's fine. All right, that's fine. That's just going to be an intermediate in the synthesis. So when we do this reaction, we want to choose a reduction reaction. I will choose sodium borohydride this time around. Okay, that's how you go from ketones and aldehydes to alcohols. Then H plus and heat. H plus and heat to give you the alkene, all right? So if you count these reactions here on this page, you've got 1, 2, 3, 4, about 24, 25 reactions. And you want to have these on a note card, and you want to go through these daily, okay? Maybe twice, maybe 2 or 3 times a day. And if you do that, you'll get a lot better at doing synthesis and picking the 2 reactions or even 3 reactions that will allow you to go from starting material to product. And that's my advice for succeeding and doing well in this course, okay? Make some flashcards and just memorize these transformations as best you can. All right, so that's it for Chapter 13. I hope these videos help you go along with the Klein textbook and read.